Hello everyone. Today Joseph Lastella, professional engineer and inventor, will demonstrate a new breakthrough in lubrication technology. For the first time ever, a new molecule will combine with 80% water to form a super lubricant that will outperform the best oil lubricant in the world by several orders of magnitude. This is not magic, this is absolute reality. Before starting the demonstration, we will explain each component of the test so that we all can understand what we are observing. The demonstration will utilize a machine called the Timken bearing test machine. The Timken company makes over 80% of all the bearings used in the world today and has been making them for over 100 years. In today's test, we will actually use a roller bearing and a race from one of the Timken bearings. The Timken bearing test machine is designed to test the lubrication capabilities of today's lubricant products under extremely high test loads. As Mr. Lastella will demonstrate with two test tubes, bearings are specifically designed to spread the applied load over a large surface area to reduce the pressure on the roller and the bearing race. However, by turning the roller 90 degrees to the race, this applies a pinpoint contact between the two surfaces and increases the pressure by several orders of magnitude. Additionally, the machine itself is designed with a cantilever bar that multiplies the load by a 12:1 ratio. During the test, we will apply 3 weights totaling 13.5 pounds at the end of the bar. Therefore, applying a total load of 12 times 13.5 pounds, which equals 164 pounds. This force is being applied to a pinpoint contact between the roller and the race. This equates to a force of tens of thousands of pounds to the point contact. To continue the test procedure, the test lubricant will be poured into a holding cup, then placed under the race. The machine will be run under no-load conditions so that each lubricant has a chance to build up a protective surface between the bearing, roller and race. This is a warm-up procedure. During the warm-up procedure, we will also take note of the required amps that are necessary to run the electric motor that drives the bearing under no-load conditions, which will be approximately 3.6 amps. During the actual test, the audience will be able to observe 4 test parameters as follows. First, the amps that are required to run the electric motor under no load and load conditions. Second, we will hear the sound bite of the actual test to determine the loudness pitch noise of the bearings that occurs in each test. Third, the actual audience, not the video audience, can smell the burning of the bearings, if it occurs. Fourth, finally, we will visualize the actual damage that has occurred on the bearing surface for each test. Let's start testing.
This is fully synthetic from Napa. Okay, everybody knows Napa. 5W30 oil, the best stuff in the business. All right, fully synthetic. We're going to put some of this in this little container, and while we're running, we're going to immerse it in that, so it has a steady source of lubrication, so we make everything absolutely even. The first thing we're going to do is determine what the no-load conditions are. So when we start this, all right, what I will do is I will turn this on. What's that reading now? 2.0, 2.1. Okay. Just that. 2.4. There we go. This wasn't close, okay? So, I'm going to take this over here. And you always want to give the bearing some time to warm up, to be an honest test. So what I'm going to do is, I'm going to take the oil, I'm going to run the bearing in it, filling it a little bit. See that the bearing is immersed in it. I'm going to let it run for a little bit. no load on it. Just to make sure that we have an oil film to protect the bearing like it would be in your car. In your car, you always have an oil film. Okay. And shut this off. You got the reading, right?
3.5.
You got the reading. So now what I'm going to do is put a lot of weight on this. I think I'll put a little more oil in there because we lost a little bit. There's something's a little loose in there. Yeah. I'm going to put the load on very slowly to give it all the advantages that you would have. You shouldn't load any bearing very quickly, but that's not an honest test. So now what I'm going to do is, I'll take the load off. I just want you to feel the weight of this. This is going to go on the end of that. Just feel that. Just feel it. You got to hold it. Put it right. You got to feel it. You got to feel it. That's a pretty healthy load. You're going to take the reading when we load it up, right?
Okay.
Okay. So I'm going to lift this up, tag this on, put the lubrication on, load it up. You ready?
Yeah.
Very slow. Very slow. Now I'm going to load it up. Heard the screeching? What was it?
5
point something.
5.4.
5.4. So you see the increase. It was 3.5,
3.5, 5.4.
5.4, almost 2 amps.
Yeah.
2 amps is a lot of load. It's 2 amps at 120 volts.
Mhm.
You know? Okay, now, there's the screeching. Let's see what happened to the bearing. What was that, 10 seconds right now?
Yeah.
Take a look at that.
Oh, wow.
Can you see it, Bill?
Right there.
Over here.
No, yes.
Oh,
Over
sorry,
here.
sorry, Joe. Sorry, Joe. I'm trying to get closer. Sorry, my fault. I got it. Yeah, now I see it. Oh my God.
I'm gonna take it off so you get a better shot of
That's a serious divot.
it. The bearing was destroyed a long time ago before it ever got that deep. The bearing got destroyed in 10 seconds. No, 2 seconds really. 10 seconds.
Oh,
Can you see that?
oh yeah.
Wanna look at it?
Absolutely.
As you can hear and see, the first lubricant failed in less than 10 seconds. The electric load on the motor increased to 5.8 amps. There was a tremendous amount of screeching and the roller has a huge gouge in it, which indicates a massive failure of the roller in less than 10 seconds. Now we are going to repeat the same test with our new Space HCNC water-soluble formula with one big difference. We are going to mix our CNC lubricant formula with 80% normal sink water and then run the same test. We intend to prove that we can take 80% water out of your sink and make it a much better lubricant than the best synthetic oil on the market today. Before starting the second test, we must clean off the roller and the bearing race to ensure we have removed all the particles from the previous tests. Also, we are going to use the same roller as in the first test, however, we will turn it around so that we can compare side-by-side damage to the roller by each test. Now we will repeat the test utilizing the same test procedure that we used on the synthetic oil. We will now run it at no load so that the oil can warm up and allow it to build up an oil film between the roller and the bearing, similar to what we did with the synthetic oil test, and read the number of load amps. It shows 3.6 amps. Now we apply the load in the same manner as the synthetic oil test. Please note the following observations. 1. The load on the motor only went from 3.6 amps to 3.7 amps. Whereas in the synthetic oil test the amps increased from 3.6 amps to 5.8 amps. Clearly indicating a significant decrease in friction on the bearing surfaces of our water-soluble CNC formula when compared to synthetic oil. 2. There was no screeching during the test, which indicates a smooth run and no failure. Also, no burning smell, which only the actual audience could verify. 3. The test continued to run quietly and gave no indication of a bearing failure. 4. Finally, let's look at the bearing itself to see if there's any damage under these extreme loads. You can see the results of the two tests clearly on the same bearing side by side. The best synthetic oil catastrophically failed in less than 10 seconds under extreme loads, whereas the 80% water turned into a super lubricant by adding our CNC formula to it. The best synthetic oil catastrophically failed in less than 10 seconds under extreme loads, whereas the 80% water turned into a super lubricant by adding our CNC formula to it. Our formula actually polished a very tiny portion of the roller and never failed. Additionally, our CNC formula has a 000 environmental rating and safety rating. In conclusion, no product in the world can duplicate this experiment. It would take a think tank of highly professional people to even understand what this could mean to the machine shop world and 100 other industries. Thank you, everyone, for your attention.